Hi, welcome to Microsoft Virtual Academy, the session on software development fundamentals. My name is Paul Party. I'm a content development lead with Microsoft, and I'm here with Jerry O'Brien.
Hi, thanks, Paul. My name is Jerry O'Brien, and as Paul said, welcome to Microsoft Virtual Academy and our jumpstart on software development fundamentals. We're going to take you through module number 6 today, which is understanding databases. It's important to note that probably about 99% of all application development done today is done through accessing data, whether it be local data on the system, if it could be a flat file, it could be a database system running in the background. You're still accessing data of some sort, and so it's important for you to understand as you start on your development career what a database actually is. Now, I want to kind of give you a little bit of level set right off the bat, and that is by the end of this module, you're certainly not going to be a database administrator, you won't be a database developer, but for the purposes of preparation for the MTA exam, Microsoft Technology Associate exam, 98-361, you will understand the concept of databases and you will understand the role that they play in software development cycles. So this module will take a look at introducing databases and talk a little bit about what a relational database management system is. And I put an RDMBS, and I think I really messed up the spelling on that one, but consider it should be RDBMS, Relational Database Management System. We'll understand some query methods, and when we talk about query methods, that basically means how we select data, so return data from a database, and how we can manipulate it. We can insert, update, and delete information. And we'll show examples of that by using Microsoft SQL Server. And then we'll close up by talking a little bit about database connections, and those come in from the perspective of, as a software programmer, you won't always be working in the SQL Server tool, but it's how you would connect your code or your application to a database itself. So, introducing databases, the module, or portion of this module, talks specifically about what a database is. And some folks know right off the bat exactly what we refer to when we say a database. And some folks probably are thinking, I might know what it is, or I haven't got a clue what you're talking about. And that's why this one is kind of important, is to kind of get everybody on the same path so that we understand what we're referring to when we talk about a database itself. So consider it to be a collection of related information. Some folks who have background or experience in databases might say, oh, that related information has different meaning when it comes to talking about RDBMS and the actual implementation of relations within databases. And yes, it does. But realistically, if we look at it from a real-world perspective and you think about your music collection at home. Now, the days that I grew up, we had records, actual LPs, the vinyl records, and we would sort them in milk crates and different things like that. Today, you have your MP3 collections sitting on your computers and on your MP3 players and what have you. And you probably don't realize that there's the ability to catalog that information. Some of you may still do it. You might have your music sorted by genre or sorted by artist type, or artists themselves. And so that's an example really of a database concept. And that is, we're storing pieces of information that typically have a relationship to each other somehow, and it's being stored in a system of some sort. So even your MP3 player, whether it's on your Windows phone, whether it's on your iPod, whether it's on your computer, through whatever software you're currently using to play those, actually has kind of a database in a sense of that information. Even though these MP3s sit as files on your hard drive or files on your storage device, we still keep track of the information, such as the artist, the genre, the song length, different things like that. So consider that kind of a database, if you will. The RDBMS, or the Relational Database Management System, takes it a step further and kind of really brings out this relational concept of the data itself. And it allows us to store information in the system in ways that deal with something called normalization, which is a database term for how we store the data in separate tables, but also how we can link those tables of information together to gain access to the information we want. When we take a look at this concept of normalization, it comes from the perspective of, if we were storing all of our data, and we'll use it as an example, the address for a person. Your specific address contains your street number, your street name, your state, your city, your zip code, So different things like that stored as your address information. And if we were storing all of this address information for 20,000, 30,000, or 1,000,000 users in a database, and we put it all in one single table, we would have a lot of repetitive information being stored in the table. And what I mean by repetitive information is, if we take a look at the state of Washington, Paul and I currently live here in Washington State. I don't even know what the population is in Washington right now, but it's rather large. And so if we had a database storing all of the residents of the state of Washington in a single table, and we repeated the state name for every resident, we're using up extra data that we don't have to. Even the city names, we've got a finite number of cities within the state of Washington. We could have 1,000,000 people living in the city of Redmond, Washington. That's 1,000,000 times we're storing Redmond as a city name in that table. So what normalization says is, well, let's not do that. Let's not waste a lot of space. Let's start breaking out the database information into what we consider discrete components of that data itself. So we would create another table that would store city names, and we would create another table that would store state names. We might even create another table that would store street numbers, although we may be going a little bit too far on that one. But what we're doing is we're taking out duplicate information, so we're pulling away that duplicate value pieces of information. Normalization deals with other aspects such as atomicity, making sure that our data is complete and that it doesn't rely on any other data that we're storing in the table itself. And it also has to relate to the primary key that's used to highlight and designate that specific information as a unique key within that table, plus other levels of normalization that we typically don't get to. I mean, we focus on usually the first 3 levels of it. But what it does is it creates a system of storing the data that is separated out into multiple tables, sometimes known as multiple entities, in discrete pieces of information about those specific entities. And we bring it all back together when we query the data by using relationships between the tables. And again, there are some database administrators who have been in the industry for years who will be screaming at me right now saying, no, it's not a relationship between the 2 tables. But for this intent, for our purpose here, that's essentially what it works out to be. We have a foreign key in one table that gets placed into another table that tells us how we can gain access to the data that is related to our record in another table. Again, we're not going to delve into normalization and get you focused on what the 3 levels are that we're talking about here and how you implement them. We're talking about concepts here, and this is what the MTA is really designed to test, is your conceptual understanding of the terms that we're using and how they relate to the database itself. We talked about the relational database management systems are typically software applications such as SQL Server. Oracle also has a database. There are other different ones out there. There are some smaller, not as mission critical intense type ones such as Microsoft Access that you could store database information in. Those are typically responsible for creating the infrastructure that you will store your data in. They deal with the services that manage that data in the back end, how it gets written out to the storage, to the disk drive itself, how we deal with backing up the data and restoring the data. When you want to extract data from it, if you write a stored procedure or a query to bring the data out, that service from the database engine is responsible for parsing that and getting the data to you that you're looking for. And so they allow us to manipulate the data by querying it and by inserting, updating, and deleting data itself. That's all a part of an RDBMS system or a database product itself. So understanding queries is the next thing that we want to take a look at. And it's a little bit maybe of a misnomer here because we're saying queries, and I always think of a query as a question. I'm asking something of the database, so I want to return data. But we'll also focus in this particular section on selecting data, updating data in a database, inserting new pieces of information into a database, and then deleting information from the database itself. These are the typical methods that you will use to interact with the database, whether from your application or if you pop open something like SQL Server Management Studio and start working within that tool itself. It's all dealing with some form of manipulating the data, returning it, or we're going to make changes to it, what have you.
And just building on some concepts that we talked about in previous modules, this could be done over the web. So you could actually have a program that makes calls to a web server and updates data remotely, or it could happen on the local machine. Where the database lives is not germane to how the queries work, because you can send queries over the internet as well. So when you update contact information, say at your bank or at another service provider that you use, a lot of times you'll be doing that over the web, and the database will be on the service provider's website, and you'll use that web interface to actually make those queries.
Yeah, so great clarifications on that, Paul, because that's true. A lot of the times when we think about working with data, again, even from a developer's perspective, when we're writing code, we're usually focused on our local machine. We're writing code on our local machine. Sometimes we might have the sample data sitting on our local machine, and we don't often think about where that data actually resides itself. And so that's a great way of looking at it, is that realizing the data could really exist someplace else entirely different from where we're at, and we're accessing it remotely. So let's go ahead and have a demo. If we switch over to the demo machine here, we'll see that what I actually have up and running right now is SQL Server Management Studio. And it probably looks a little cluttered. If you haven't seen this before or gotten used to this before, we can make it a little less cluttered by kind of really reducing the expansion that I had on the database. But this is a graphical tool that allows us to work with the database itself directly. And again, as Paul mentioned earlier, that we could potentially have this system actually executing and running on another system someplace else altogether. Okay, so what we're looking at here is SQL Server Management Studio accessing a database locally on the machine. Over here on the left-hand side is what we call the Object Explorer, and this shows us our databases that we have connected to the system. And AdventureWorks 2012 is just one that you can get off of CodePlex. If you go search for AdventureWorks or SQL Server sample databases, that's exactly what this database is. We talked about creating tables in a database, and this is an example of the tables that we would see in a database itself. They have very specific names, human resources, job candidate, person.address. So this is an example of what we talked about a little bit earlier, storing the address for a specific person. And if we expand that and take a look at the columns that make up that table, we can see that we have an address line 1, an address line 2, a city, a postal code, spatial location. And this is an example of where if we really wanted to press the normalization aspect that we were talking about, we would pull that city value out of there and put it in a city table. If you take a look at this, person country region, you can see an example of that in the columns, that we actually have a country name and a country region code. And that's an example of pulling, specific data out of that person address table. But we still represent that kind of relationship to person through the use of the person dot, so in the table naming scheme. But we're going to focus on a couple of different tables in this one here as we start looking through examples of manipulating the data by using the queries. And so, the person address one is what we'll focus on specifically. So as an example, in this scenario, we're going to execute a query that returns values back from the database. And there's nothing special about this query. We're just saying, I want to look at everything or all records that's in the person.address table. And the select is the keyword that says select the data or return the data. Where am I going to get it from? Person.address. So I want to get it from the person.address table. And what do I want? Well, I want everything. That's kind of what that little asterisk symbol means. You just give me all of the data or everything from there. And so we go ahead and execute this one section, and we can see that the results get returned. And we can actually look at, so here's the address ID, here's the address line 1. So you can see how all of these different columns in the results that are returned actually map to the values that we had, or the columns that we had available in the table itself. So this is just an example of returning information from a database. It's a simple select query. The thing that's kind of interesting to think about from this perspective is SQL Server itself will kind of execute this query a little bit differently. And when I talk about, earlier where I said the database engine is responsible for parsing the queries and doing the processing necessary, SQL Server looks at this and says, all right, first thing I want to execute is this from. I need to know where you're going to pull the data from. before I can know what data you're going to grab. So in other words, it needs to be aware of the data source. In this case, it's the actual table itself. Then you can tell me what it is that you want to select. So SQL Server will actually flip this, or kind of flip it on its head a little bit. And it's what makes understanding how the processing of queries work in SQL Server sometimes a little difficult for folks, because we think in the way syntax, the way this is written, I want to select something from a certain table. And SQL Server actually has some built-in, what we call IntelliSense, which was, our Visual Studio tools have IntelliSense built in, and SQL Server has been adding it over the years as well. And it gives you a little bit of an understanding of how that works. If I start to type this select statement again, assuming I can get my fingers to work on the keyboard properly, and if I select, and in this case I wanted to deal with, let's say, address line 1, as you can see, like, the IntelliSense is coming up and it's giving me some suggestions here, but it doesn't really know what it is that I'm looking for, because it doesn't know where it should expect to get it from. If I instead change this to say from person.address, so that SQL Server now knows where I'm getting it from, watch what happens when I start typing in now. See? So you can see how SQL Server, now it says, oh, I got it. Okay, you want from this table. Well, here's the list of values that kind of sound like that. So this just gives you a visual way of seeing that this is actually the way SQL Server processes that command. It wants this first, so it's going to look through that first. Let's just pop that out of the way for the time being. Now, again, the first one that we executed, select star from person address, is just a way of saying select everything. I'm not being specific. I don't care what you return. I want to see all data in that table. We've also got a way of saying, well, I want specific pieces of information. And in this case, I want to see all of the information, again, because I've specified the star. So select all fields from the person.state province table, but I only care about those who are in state province ID of 79. That probably doesn't mean anything right now, but let's just execute that for a second. And we see that we have pulled from the person state province table all fields, so we got the ID, the province code, the region code, etc., where the state province ID equals 79. How did I know that 79 would return a value? Well, technically I didn't. So if I comment this line out so that it doesn't execute in my code, this is what I would have done at first, was simply executed this, select star from person.state province. And the reason that I would do that is because I want to see what the valid values are that I'm going to query against. So even querying the database sometimes requires you to know what data is being stored in the database and how it's being represented, okay? And that allows you to actually go in and query the information that you're specifically looking for. A good example, if I go back and talk about some of the students that I taught in a previous course a few years back, when they were just learning database technology, and a lot of these students had no concept of databases. They didn't know what they were, and they didn't know how to work with them specifically. The database setup that we were using was mimicking a real estate database system. And the scenarios that we would give them were that they were working as the business administrator for a real estate office. And the manager came in one day and he said, look, he said, I got a customer who's interested in properties that have 3-car parking garages and or parking for 3 cars, and they have 2 bathrooms and they have a minimum of 4 bedrooms. Go ahead, query the data, bring that information back to me. And when I first gave them that direction and they went off, and everybody in the class came back and said, there are no records that match that. And they said, well, yeah, I know that there are, because there are actually 20 records in the database that match it, and I showed them what there was. What they failed to do was understand how the data was actually being stored in the system. So they were able to get number of bathrooms, the number of bedrooms was no problem, but this whole parking concept really messed them up, because I only said to them, I need to know if I can park 3 cars. And so immediately they were just trying to write the query that said, well, 3 cars, but there wasn't anything in the database that actually said 3 cars. So they didn't realize they had to go look at parking as the table and determine which of those properties had parking for 3 cars. So again, your queries that you're going to execute against your database are only successful if you understand the data that's actually being stored in that database. It's important to know. So let's go back to our demo again, and we'll take a look at some other information. And what we're going to do here now is we're going to take a look at how we can actually make some changes or manipulate data in a database. And what I want to execute first is this select statement that will simply return all of the fields from the person.person table. And the reason that I want to do that is I wanted you to take a look at what we have available here for a couple of records. And the first one, we're going to make some changes or updates. I just want you to focus on item number 5 here. So we have Ms. Gail A. Erickson in this database or in this particular system. What I want to do is I want to make some changes, and I want to say that initially, just throwing a scenario out here for you to think about, perhaps when I entered the customer's information into this person table, I didn't have Gail's middle name. I only had the middle initial. Now somebody come back and said, hey, we've got Gail's full name, and we want to put Gail Angela is her middle name. We want to put that into the system. So we want to update the information. So what I've done then is I've issued an update command, and I simply told it I want to update the person.person table. And then again, thinking about how computers function, we have to be very explicit in telling them what we want them to do. If I just said update person.person and Gail's middle name, the system is not going to know what to do with that. So I have to say I want to set the middle name equal to the text string Angela, and this is the middle name column, but I only want to set it on a customer whose first name is Gail and last name is Erickson. So this where clause is what's known as a filter clause when we're working on stuff. And if you're going to be doing updates and deletions specifically in a database, you really need to be aware that sometimes the changes you make can be far more reaching than you anticipated them to be. And this will actually show an example of what that means. So we look in this and I see that there's a Miss Gail A. Erickson in here. So I'm just about as happy as I can be because I've found Gail, and I'm going to update Gail's middle initial to Angela. So I'm going to change that and update that process. And I go ahead and I execute my code, and it said 2 rows were affected. Well, how did that happen? I mean, realistically, so right off the bat, I know that, okay, if I did a select all from the person.person table, I only looked at this first record for Gail Erickson. That means that there's another Gail Erickson somewhere in that table. So ideally what I should have done was, even when I selected this, I should have included a where clause in here where I said first name, let's use the IntelliSense so I don't have to type too much, equals Gail, and last name equals, and what did we say was Erickson? Yeah, it's right there on the screen. And, oops, I wanted to close that out with this. And then if we execute this, we can say that, yeah, indeed, there was 2 entries for Gail Erickson in here. There's something different about them. They each have a different business entity ID, so there's obviously something in that system that says there's 2 Gail Ericksons for a reason. But as a result of executing this update code, I potentially have just corrupted my database. All right. So that's just a way of letting you know that when you start issuing updates and deletions on data, be very careful what you're doing with that information. You could inadvertently overwrite something, and then you've created a data integrity problem in your system. So just to be aware of some of those potential issues.
And by the way, Jerry's showing you how you can modify data using SQL Server directly, so you're operating directly against the database. But you can imagine, leveraging the modules that we showed earlier. You can imagine creating programs that would do this for you. So a user would have a form. They would write in what's the name of the person, the first name of the person you want to modify. You put in the first name, put in the last name, and then there would be a field that says what field do you want to modify, and you can select that field and then show the update value. Click submit. and then this would happen behind the scenes, and the program would take care of that for you. But we're showing you how you can do this against the data directly using SQL Server in a query language.
Right, exactly. And one of the things to keep in mind too is typically in the environment, and as Paul mentioned, if you were writing the code yourself and you wanted to insert, update, or delete data in a database, if you're working as your own developer and database administrator, then you have full control of both environments and everything will work perfectly fine. In most production, real-world type of environments, you're going to have somebody who's responsible for the database, which will likely be a database administrator or a database developer that exists. And they're not going to let you actually write this code that we've been demonstrating in your program code. They will say, you tell me what it is that you want to do. I will write this thing called a stored procedure, and you simply call it and pass me the information. I'll take care of that on the back end. Mm-hmm. So there's a number of different ways that you can manipulate data in a system, as we're doing here with SQL Server directly or through program code. But again, depending on your environment, you might not be writing this yourself, but it's important for you to understand how these SQL statements execute and how they function so that you've got a better grasp of how data is manipulated in the database itself.
That's right.
Right. So next we're going to take a look in our demo again at how we go through the process of doing some data deletions and data insertions. So let's go back to our demo machine. And in this particular instance, I'm going to insert a value. And in order to do that, and again, I'm just trying to keep some of these demos as quick and simple and easy as possible. So, I apologize jumping across different tables, but it's just designed to make the demos quick, to make them simple, without generating too much clutter in the system. We're going to jump over to a table called production.culture. And if we execute production.culture select star, this is an example of a table that would store culture information that relates to, let's say if we're developing an application and we want to be able to deploy it around the world, we want to be able to determine as a user comes in what their locale is around the world. So we can localize that application in their language. Users visiting a website, as an example, have their locale specified on their computer. The web application can read that locale and say, oh, you are currently executing this application from France, so that means that I should display the results or the pages to you in French. And so this is what kind of this culture ID is used for. You can see that we have some existing ones in here already. There's AR for Arabic, EN for English, ES for Spanish, FR for French, and Hebrew, etc. So this was the table that I wanted to manipulate, and mostly from the perspective of it's the easiest way to show you inserting a new value, because this table is not complex. There's not a lot of values that are in here. So to insert a new value, if anybody from is watching this from Canada, you'll understand why I would have to insert a Canadian French culture ID in here. We won't go into those values, but Canadian French is slightly different from the France French. We need to have a different culture ID. So we're going to insert a new value. We're going to insert this into the table. So I will execute the insert, and the success I see because it says one row has been affected. And now if I come back and I execute my select against that same table, you can see that indeed we have actually added that new value into the table. Now, there's a couple of different components to this that might need a little bit of explanation. First of all, it's relatively easy to see that we're inserting this textual value called CA-FR for Canadian French. That goes into the culture ID column. How do I know that? Well, because of the order in which I have put them in these parentheses. Culture ID is my first column. Name is the second, and the Canadian French goes in as the culture identifier for that. And then this one by itself looks kind of odd, or a little bit on the strange side. And if you've never done a whole lot in the way of SQL Server, get date might not necessarily mean anything to you, but it's a function in SQL Server. So somebody actually wrote code for this at Microsoft, obviously, that does this. And what it does is it returns today's date. It goes out to the computer and says, hey, what's today's date? And it returns that value with the date timestamp, and it populates it here into this field. And the reason I had to do that was because we've got a field called modified date. And again, when we start thinking about data integrity, as you start looking at inserting, updating, deleting, and modifying the data in the database, you should always be aware of data integrity. You don't want to be messing things up. You don't want to be creating issues or potential problems with the data. By issuing or executing that getDate function, I continue to provide data integrity by being consistent with what was in the table. So if we go back and look at that table again, we can see that all of the other entries, even though we didn't make them, they all had a modified date column. That could be important from the perspective of us going back at some point in time and knowing when cultures were added to the database. So we know when something was changed or modified. It can help us troubleshoot and debug later on down the road. So that's just an example of doing data modification. We've inserted a new value. Previously we had updated a value. And the last thing we want to focus on is, well, we decide that we don't want this anymore, so we're going to delete this. So we have a delete command that we can actually execute. And kind of like the update command, we're being very specific. In the insert command, we're just saying insert into this table, and here's a bunch of values, because it's a new record, so we're not really going to impact anything. But let's come back here and think about this update. We are updating existing data, so we've got to be very careful about what we do. And we're specific about setting what field and putting a criteria in there to make sure we're doing what we want. In this case, we're going to delete some values, so we're using the delete keyword. Again, we still have to tell SQL where do we want to remove it from, so we're giving it the table name. But if I just said delete from production.culture and executed that, I'll wipe out everything in that table. That's not what I want to do. What I want to do is put my condition in to make sure that I'm only deleting what I want to delete. In this case, it's the culture ID that I inserted called ca.fr. So I'm very specific on my filtering condition. I'm telling SQL Server, go into the production.culture database, find the record that has a culture called ca.fr, and when you find it, delete it. That's essentially what I'm telling SQL to do. So let's find out if it works. We execute F5 on that. One row has been affected. Thankfully, it wasn't more than one row because that would have meant I did something wrong. And let's come back in and just query that table again to see that indeed the Canadian French culture ID has been removed from that table. So very quick and simple. That's kind of demonstrating, inserting, updating, and deleting data from within the SQL Server database itself. And again, as Paul mentioned, we're focusing on using a tool that's connected directly to the SQL Server database, SQL Server Management Studio, and that's where we're getting that functionality from. The last thing we want to talk about in this module is we're going to focus on connecting to databases. So again, as Paul alluded to, we could be connecting to the database and manipulating the data if we're writing code ourselves and we are connecting to a server across the internet somewhere, or even just across the network. It doesn't have to be the internet. It could be some kind of a network somewhere. So we're going to do a connection inside of our application code itself. Now, we're not going to do that in code, so we're not going to open up an application. We're not going to go through the process of creating a connection to a database and writing queries. That would be really all-encompassing and very time-consuming. You'll get into that as you start coding database applications or applications that access data later. As a high-level overview so that you understand the concepts, this is what we want to talk about here. Database connections are required for a software application to access data, assuming that is that we are accessing data from a relational database management system like SQL Server. If we're accessing data in an XML file, which is considered a flat file data source, that could just be local. We don't need a connection string. We can just open that with other methods. But in order to connect to an actual database management system, your code will need a database connection. Connections can be pooled, and that second bullet point is kind of interesting because as you think about multi-user applications, we could have multiple users in our environment using our client application and they're connecting to a database backend such as SQL Server. If we don't want to overload that server, if we want to be able to have users access and bring the data back with a relatively well-performing application, then we should start focusing on connection pools. And what a connection pool does is it's a collection of available database connections. Think of it from that perspective. And what it means is that we can only have X number of people connected to this database at any one time. Usually it's done, again, for performance reasons, and you can talk to your DBA about how databases start locking information and making it difficult or impacting the performance as multiple users start updating, inserting, and deleting data in the same system. But the connection pools allow us to connect to a database, and when we're finished, we should close it out. And that's very important, is you open a database connection, which means you're connected to the data system. You do whatever it is that you need to do for the data manipulation, query, what have you, and close that connection and get back out of there because it allows other users to connect to that system again. The database connection pools have the ability to actually automatically close out idle connections. So if somebody has written code in an application and they connect to a database but it never closes it, whether they're using it or not, that's a connection that's sitting idle and not being used and preventing somebody else from gaining access to the system. We've got the ability with connection pools to set timeouts so that if a connection is idle for a certain period of time, we'll drop that connection out.
And that could be a security risk as well.
Again, yeah, absolutely can be a security risk because you don't want connections open to your database, especially if it's connected to the internet and across public networks. And so the last bullet point on here just kind of gives you an example of what you might see if you're writing a database connection string in your code. Now, fortunately, things like the entity framework that we have in the Microsoft.NET framework makes a lot of this connectivity stuff even easier now. There's a lot of just setting up a few configuration parameters and it generates all of this code for you. But it's important for you to understand what you might see. So looking at this connection string, we give it a name. That's what that m_s con str is. Thinking back to if you've been present through all the previous modules, what a variable is, it's another representation of a variable in our code. And then what we're assigning to it are very specific parameters, and database connections are very specific in how you connect to the different types of databases and the parameters that are required to make that connection successful. In this case, we're saying that our provider is a SQL OLE-DB, which means a SQL server. And OLE-DB, I'm not sure if it still actually stands for Object Linking and Embedding Databases, but there was actually a whole term that acronym stood for. But the provider is known as SQL OLE-DB, and that basically means that I expect to access the database through a specific set of APIs or calls that I can execute on it. The data source aspect of it says what server I'm going to connect to. So what's the name of my SQL server that I need to, or whatever database we're connecting to. What's the name of that server? So I have to be able to get to the server by name. The initial catalog says Northwind, so that means that's the name of the actual database in that database server. In our case, we were demonstrating in SQL Server AdventureWorks, so Northwind would be replaced by AdventureWorks 2012 in this case here. And then the last aspect is integrated security equals true, which is one way of saying when I connect to the database, use my currently logged in credentials. So if I'm logged on to a Windows system right now, which I am, and I tried to connect to a database on another server, it would check my Windows credentials to see if I was authorized to gain access to that database. We can also deal with database logins, in which case your connection string might have a username and password built in. Not a good idea from a security perspective because people can gain access to your connection strings as well. But again, this is just one example. There are many different types of connection strings, and they're all based on the database that you're going to connect to or the type of developer language or technology that you're using. So don't think of this as, this is the gold standard of what you're going to be looking at for connection strings. It's just designed to give you an idea of what you can expect to write in your code. So that's all we have to cover in this module on database connections and databases themselves. So just to kind of recap what we've looked at, we took a look at understanding what databases are, gained an understanding of what a relational database management system is, how those systems actually store information within the database for you to gain access to. We provided a demo of returning data and querying the data, manipulating it, and seeing what it was that we could do with it, inserting it and deleting data. And then we closed out by looking at how you as a software developer might connect to a database in your application code. So hopefully you've gained some insight into what databases are, how they'll impact your software development moving forward. And we hope you've enjoyed what you've seen in this session. Paul, anything you want to add?
No, I think that was great. Just one minor thing, just to plug for Microsoft. When you're looking at database options, Windows Azure is a great an opportunity to create databases, and particularly in the new Visual Studio tools, a lot of the database connections are taken care of for you. So that would be a good place to start, just implementing a database in your applications. But knowing all this this underlying technology is also really valuable as well.
Yeah, absolutely. Great pointers on that, Paul. Thanks. So once again, thanks for joining us for this module, and be sure to come back for our final module, module number 7, where we'll talk about whether this is for you or not based on everything you've seen in this entire Jumpstart. Thanks very much.
Thanks, Jerry.